supervolcanoes. I mean, just the word itself is enough to give you chills, right? It brings up these epic images of global disaster, this immense power rumbling just beneath our feet. And yeah, it's a source of endless fascination, but also, let's be honest, a little bit of fear. So what's the real story here in 2026? What is the planet's fiery pulse actually telling us? Okay, let's get right into it.
So this is the big one, isn't it? The question that's always in the back of our minds, thanks to blockbuster movies and scary headlines. Is one of these monsters about to blow? And while it's definitely a dramatic thought, the real story, the one that the latest science is telling us, is so much more complex and, frankly, way more fascinating. So let's separate the Hollywood hype from the hard facts.
Now, the good news here is that we are absolutely not flying blind. Scientists have these massive volcanic systems under constant surveillance, 24/7. So what we're going to do is open up the case files on some of Earth's most powerful volcanoes. We're going to look at the freshest evidence from the last year or so to see what's really happening down there.
All right, case file number 1 has to be the most famous volcano on the planet, Yellowstone. We've all heard it a million times, the myth that it's overdue for some world-ending eruption. But here's the thing, a truly groundbreaking study in 2025 just completely rewrote the book on what's happening beneath that beautiful park.
You know, this right here is what I find so cool. The old myth, the picture we all had in our heads, was this one single massive lake of molten magma just waiting to explode. But the reality, thanks to that huge study in the journal Nature, is totally different. Instead of a giant lake, you need to picture something more like a big, wet, crystalline sponge, where the magma is trapped in thousands of tiny, separate little pockets. And this data is the real kicker. Yeah, there's milk down there, a lot of it. But look at that key word, disconnected. For a supereruption to even be possible, all those little pockets would have to somehow connect into one giant blob. And right now, they just aren't. And that's exactly why the official alert level is still at normal/green. So to put it simply, Yellowstone is not about to blow its top.
Okay, so for our second case file, let's hop across the Atlantic. Because while Yellowstone is pretty quiet, there's a massive volcanic crater, a caldera, in southern Italy that is very, very much awake. It's called Campi Phlegraean, and this isn't some far-off theoretical threat. This is real, measurable unrest that's happening right now. So the activity there is driven by this wild phenomenon called bradycism. And I know, it's a mouthful, but the concept is actually pretty simple to picture. It just means the ground is slowly rising and falling. At Campi Phlegraean, it's almost like the entire landscape is taking these slow, deep breaths. And let me tell you, those breaths are having a huge impact.
For example, just look at this number, 6,740. That's the record-breaking number of earthquakes that region felt in 2024 alone. And we're not talking about tiny tremors only a seismograph can pick up. People are feeling their homes shake constantly.
And all that shaking is doing this. 148 centimeters. That's almost 5 feet. That's how much the ground in the middle of the caldera has been literally pushed up since 2005. The earth there is physically swelling.
The shaking really peaked in 2025 with a magnitude 4.6 earthquake. Now, that might not sound huge on a global scale, but it's more than strong enough to cause damage and put an entire metropolitan area on high alert. So what in the world is causing all this?
And this is where the science gets just incredibly clever. Late in 2025, researchers took the data from over 54,000 earthquakes and fed it all into an AI. And what it spit out was amazing, a hidden ring fault system nobody knew was there. So the leading theory now is that it's not fresh magma rising, but superheated gas and water that are getting trapped and pressurizing these faults, making the ground lift and shake.
All right, for our third case, we're going for a dive. I mean, literally, deep underwater off the coast of Oregon to this incredible natural laboratory called Axial Seamount. And it's a fascinating story about a missed prediction, but it's also a perfect example of how science actually gets stronger when it gets something wrong. See, scientists had this volcano's number. They successfully predicted its 2015 eruption. So based on how much the seafloor was swelling up with magma, they made a new forecast for another eruption by the end of 2025. But then, 2025 came and went. And nothing. The volcano didn't erupt. So what happened? Did the volcano suddenly change the rules of the game? Well, yeah, in a way it did. The new theory is this idea called crustal stiffening. The best way to think about it is like trying to inflate a balloon you've already used a bunch of times. It gets a little tougher and less flexible. It seems that with each past eruption, the volcano's crust gets a bit stronger.
So now, it simply needs to build up even more pressure inside before it has enough oomph to burst through. Science didn't fail. It just learned the system got an upgrade.
Okay, so we've been deep in the details on these specific cases. Let's pull the camera way, way back and talk about the big picture. What are the actual, real-world odds of a major climate-changing eruption happening anytime soon?
This chart uses what's called the Volcanic Explicitity Index, or VEI. Just think of it like the Richter scale, but for volcanoes. Now, in any given decade, there's about a 60% chance of a VEI 5 happening somewhere. That's like Mount St. Helens. The odds of a VEI 6, like Pinatubo back in '91, drop to around 15%. And a truly monster VEI 7, like Tambora in 1815? Well, there's only about a 1.2% chance of that in the next 10 years.
And what about that Yellowstone supereruption we're also fascinated by? The annual probability is this tiny number right here, 0.000014%. To put that into perspective, your odds of being hit by a kilometer-wide asteroid are basically the same. It is a risk, technically, but it's an extremely remote one.
So, if a super eruption isn't the main headline, then what is? The real takeaway here is that we live on a planet that is constantly moving, constantly breathing, constantly in motion. The real story isn't about some single looming catastrophe, but about this incredible, continuous, dynamic change happening all the time. I mean, just think about this. As of late 2025, there were 45 volcanoes in a state of continuous eruption around the world. 45. That's not a crisis. That's just the normal state of affairs for our planet. It is a world in motion. So this is what volcanologists are actually focused on for 2026. These are the big questions. For axial seamount, it's, will it finally build up enough pressure to get past that new, tougher crust and erupt? For campy Phlegrae, how will all that hot water and gas interact with those newly discovered faults? At Yellowstone, they're trying to figure out what a tiny bit of new uplift on the Caldera's north rim actually means. And down in the Andes, at Laguna del Mal, they're wondering if one of the fastest rates of ground swelling on the entire planet is going to continue. So I think the main takeaway from all of this is that these giants, they are absolutely awake. But they're not necessarily angry. They're just living, breathing systems that are always changing. And with every single earthquake, every puff of steam, every centimeter the ground rises, they're telling us secrets about the inner workings of our own planet. The only real question left is, what are they going to teach us next?